October 23, 1942. 6:47 hours. The western desert of Egypt, 9 miles west of a dusty railway stop called El Alamein. The air itself is a physical thing here, thick with fine sand that gets in your teeth, your eyes, and the deepest moving parts of any machine man is foolish enough to bring into this godforsaken ocean of grit. And right now, that machine is an M4A1 Sherman tank, serial number 3034, bogged down to its belly plates and utterly, hopelessly stuck. Standing beside it, his face a mask of controlled frustration under a film of dust and sweat, is Engineering Lieutenant James Caldwell. He's 29 years old, but the desert has a way of aging a man, carving new lines around the eyes with every sunrise. He's a graduate of the Massachusetts Institute of Technology, a man who understands the elegant, unforgiving language of fluid dynamics. Here, that language is spoken by millions of tons of sand, and it is telling him that his 30-ton war machine is going nowhere. The grinding shriek of the Sherman's tracks is a useless, infuriating sound as they spin in place, churning the pale sand into miniature whirlpools, digging their own grave with every revolution of the sprockets. The tank commander, a kid from Ohio barely out of his teens, has his head stuck out of the turret, his expression a mix of hope and despair aimed squarely at Caldwell. Some 875 yards away, through the shimmering heat haze, the angular silhouettes of 3 Panzer IVs are repositioning themselves on a low ridge. Their long-barreled 75mm cannons glint in the early morning sun like the eyes of patient predators. Caldwell doesn't need a watch to know the math. He has less than 4 minutes before those German gunners have a clean, direct line of fire. 4 minutes until his mechanical problem becomes a tactical catastrophe. The problem, as any GI in a Sherman from the 2nd Armored Division, the boys from Hell on Wheels, could tell you wasn't new. It was a recurring nightmare that no training manual back at Fort Knox had ever prepared them for. Ever since the first M4 Shermans had arrived in North Africa in September, they'd been facing an enemy more relentless than the Afrika Korps, the very ground beneath their tracks. These were good American tanks, built with American steel and American know-how, designed to roll across the hard-packed fields of Europe. But here, in the soft, shifting sands of the Libyan desert, they sank like stones thrown into a pond. The numbers coming back to headquarters were devastating, a quiet litany of mechanical failure that was costing lives. Of the 318 M4 Shermans deployed in the initial North African campaign, a staggering 127 had been rendered immobile not by enemy fire, but by simple, brutal physics. They were bogged down, sitting ducks for Rommel's 88s. An M4A1 weighed in at 30.3 short tons. That's 60,600 pounds of prime American hardware. The surface area of its tracks making contact with the ground was approximately 30.1 square feet. Do the math and you get a ground pressure of nearly 14 pounds per square inch. The problem was, the loose, granular sand of the western desert could only bear about half that, somewhere between 6 and 8 psi, before it gave way. The result was as predictable as it was lethal. A Sherman would roll forward, maybe 55 yards, sometimes a good 110 if the driver was lucky and the ground was firm. Then, inevitably, the crew would feel it, a subtle drag, a loss of momentum. The tracks would begin to churn, to bite deeper instead of moving forward. A green driver's first instinct was to goose the throttle, to pour more power from the magnificent 400 horsepower Wright R975 Whirlwind engine into the drivetrain. But that was the worst thing you could do. Instead of surging forward, the tracks would simply excavate, digging furiously until the 30-ton behemoth was buried up to its chassis, its armored belly resting on a pillow of sand it had just dug for itself. Meanwhile, the German Panzer IIIs and IVs, whose designs had been refined on the soft soils of the Eastern Front, were fitted with wider tracks. They skated across the very same sand, as if it were paved asphalt. The loss ratio was humiliating. For every panzer the Allies knocked out, the Afrika Korps was immobilizing or destroying 3.2 of our Shermans. General Bernard Montgomery, the stiff-lipped British commander of the 8th Army, had been barking at his engineers for weeks to find a solution, any solution. The answers that came back from the motor pools and field workshops were all variations on a theme, and none of them were good. Haul massive steel plates out into the desert to lay down in front of the tanks, a logistical nightmare. Fit the entire fleet with wider tracks, a process that would take weeks, requiring parts that had to be shipped from factories halfway around the world. Restrict all armored operations to the few patches of hard, rocky ground, a tactical straitjacket that would hand the initiative to Rommel on a silver platter. None of it would work, and time was a luxury they didn't have. The main push of Operation Lightfoot, the offensive that would become the Second Battle of El Alamein, was slated to begin in less than 72 hours. There was no time for complex, factory-level solutions. They needed a fix, and they needed it yesterday. Caldwell had been chewing on this problem for days, watching it from a different angle. While every other engineer was obsessed with the tracks, the point of contact with the ground, he found himself staring at something most tankers considered irrelevant: the road wheels. The M4A1 Sherman had 12 bogie wheels, 6 to a side, each fitted with a solid rubber tire. Their job, according to the manual, was simply to guide the tracks and absorb some of the shock on hard terrain. The full weight of the tank was borne by the steel of the tracks themselves. But Caldwell, with his MIT-trained brain, saw something more. He saw that those solid rubber tires determined how the track distributed the tank's weight onto the ground. He'd noticed something crucial during a maintenance check. The solid rubber tires were rigid, inflexible. When the tank moved over the sand, the tires didn't deform, didn't flatten out to spread the load. They remained hard as rocks, creating pressure points along the track, concentrating the tank's immense weight into small, specific areas. And that's when the idea hit him, an idea so contrary to established doctrine, so outside the bounds of military engineering, that he knew his superiors would instantly dismiss it as madness. What if he filled the road wheel tires with water? The logic was counterintuitive, but to a man who understood fluid mechanics, it was perfectly sound. Water, unlike air, is virtually incompressible. But unlike solid rubber, it is fluid. A tire filled with water under pressure wouldn't be rigid. When it pressed down on the track, which in turn pressed on the sand, the water-filled tire would deform. It would flatten slightly against the inner surface of the track. This would dramatically increase the contact patch, spreading the tank's weight over a much larger area without compromising the structural integrity of the suspension. More surface area meant less pressure on the sand. Less pressure meant less sinking. It was a simple, elegant theory. But there was an enormous, career-ending problem. U.S. Army regulations explicitly, and in no uncertain terms, forbade any unauthorized field modifications to armored vehicles. The Bible for any Sherman mechanic, Technical Manual TM 9-731B, was crystal clear on the matter. No alteration to suspension components shall be performed without direct authorization from the Department of Ordnance. Violating that directive was a fast track to a court-martial. Caldwell knew he couldn't just walk into Major Henderson's tent and propose this harebrained scheme. He needed proof. Hard, undeniable proof. On October 24th, at the ungodly hour of 2:34, the desert camp was cloaked in a deep, profound silence, broken only by the whisper of the wind and the distant cough of a generator. Under the faint light of a sliver of moon, Caldwell and 3 mechanics he trusted with his life crept toward an M4A1 designated as a maintenance vehicle. There was Sergeant Robert "Sarge" Mills, a grizzled veteran from Pennsylvania who'd been fixing engines since before Caldwell was born, Technical Corporal Frank Harrison, a lanky kid from Chicago with a magician's touch for machinery, and Private First Class Joseph Reeves, a quiet farm boy from Iowa whose hands were as strong as forged steel. They worked in the shadows of the motor pool, their movements practiced and silent, communicating with hand signals and hushed whispers. Using a manual water pump borrowed from the quartermaster and some improvised hoses, they began the laborious process of filling the 12 road wheel tires. Each tire had a capacity of about 4.75 gallons. In total, They carefully pumped just over 57 gallons of precious water into the tank's suspension system. The added weight was 476 pounds, a negligible amount, less than 1% of the tank's total mass. By 4:17, as the eastern sky began to pale from black to a deep indigo, the modified Sherman was ready. Caldwell swung himself into the driver's seat, the familiar smell of grease and hot metal filling his nostrils. Sarge Mills, his face grim, climbed into the commander's position in the turret, his hand resting on the .50 caliber machine gun more out of habit than necessity. Their objective was simple and terrifyingly risky: drive the tank across the very same patch of soft sand where 3 other Shermans had gotten themselves hopelessly mired the day before. Caldwell hit the ignition. The 400 horsepower Wright R-975 Whirlwind radial engine coughed to life, its familiar, throaty roar shattering the pre-dawn stillness. He eased the tank forward, the levers feeling heavy and sluggish in his hands. Harrison and Reeves watched from a nearby dune, binoculars pressed to their eyes, their hearts in their throats. The Sherman reached the edge of the soft sand patch. Caldwell held his breath, keeping his speed steady at a crawling 5 miles per hour. The tracks bit into the sand. He braced himself for the familiar lurch and drag, the sickening feeling of the machine beginning to founder. But it never came. He felt a strange buoyancy, as if the massive 30-ton vehicle were floating. The tracks weren't digging in, they were riding on top of the surface. Caldwell pushed on. He crossed the 200-yard mark, then 300. At the 500-yard point, where the third Sherman still sat, a monument to their failure, his modified tank was still moving, the engine humming contentedly, no sign of strain. Mills, his head poking out of the turret, was staring down at the tracks in disbelief. They were leaving impressions in the sand, yes, but they were shallow, barely 3 inches deep instead of the usual 16-inch trenches. Caldwell brought the tank to a halt. He put it in reverse, backed up, then moved forward again. He executed a 90-degree turn, the most demanding maneuver in loose sand, a move that would almost certainly bog down a standard Sherman. The tank responded without a hitch. No sinking, no loss of traction. Total time for the test, 11 minutes. Distance covered over soft sand, 920 yards. Average track sinkage depth, 3.5 inches. For comparison, a standard Sherman would have been hopelessly stuck within 65 yards. At 6 o'clock hours, a dust-covered but triumphant Caldwell stood before Major Charles Henderson, the ranking engineering officer for the British 8th Army. Henderson, a man whose face seemed permanently etched with the worries of command, read Caldwell's hastily scrawled report twice, his expression unreadable. He looked up, his gaze sharp. "Let me see this tank, Lieutenant." Caldwell drove the modified Sherman himself, with Henderson watching every move from the turret. The major dismounted, walked around the vehicle, knelt in the sand and measured the depth of the track marks with a ruler. He inspected the water-filled tires, tapping one with his knuckle. His first question was direct and to the point. "Does this violate regulations from the U.S. Department of Ordnance?" "Yes, sir," Caldwell replied, his voice steady. "Completely." For the first time in what felt like weeks, Major Henderson smiled. It was a thin, tired smile, but it was a smile nonetheless. "Perfect, Lieutenant. You have 48 hours. I want every Sherman in the 2nd Armored Division modified." What followed was a masterclass in American logistical ingenuity, a frantic race against the clock. Caldwell organized his mechanics into 3-man teams. They worked around the clock under the brutal desert sun and the cold desert nights. Each team could modify one tank in about 90 minutes. The process was simple but required precision. Bleed all the air from the roadwell tires, connect the water hoses, fill each tire to an optimal pressure measured with improvised gauges, and then seal it airtight. In 46 hours, 87 Sherman M4A1s were modified. The water used came directly from the troops' own drinking supplies, a total of 4,964 gallons, enough to supply 400 GIs for 3 days. But General Montgomery, when briefed, deemed it an acceptable sacrifice. On the night of October 23rd, at 21:40 hours, the Second Battle of El Alamein began. The desert erupted in the largest artillery barrage since the Great War. 882 guns opened fire simultaneously, a rolling thunder that lit up the horizon and shook the very sand under their feet. At 2200 hours, the British infantry began their advance. Then, at 1 o'clock on the morning of the 24th, it was the tanks' turn. Captain David Reynolds commanded a company of 12 modified Shermans. His objective was to punch through the German lines across a 3.1-mile-wide stretch of soft sand, a sector the Germans considered utterly impassable for heavy armor. Rommel's intelligence was good. He knew the Shermans couldn't cross that sand, so he had concentrated his deadly anti-tank guns on the firm ground of the flanks. The center, that wide expanse of soft sand, was defended only by infantry and a few scattered mortar positions. The Germans were confident that the desert itself was their best anti-tank weapon. Reynolds gave the order to advance in a wedge formation. The 12 Shermans revved their engines and surged forward into the darkness, toward the sand. German observers on the front lines saw the hulking silhouettes approaching and felt no alarm. They had seen this play out dozens of times. The American tanks would advance for 50, maybe 100 yards, and then they would founder, becoming easy, immobile targets for their mortars and Pak-40s. But this time was different. The Shermans hit the soft sand and simply kept coming. They didn't slow. They didn't sink. A wave of confusion, then panic, rippled through the German trenches. They opened fire with their machine guns, the bullets pinging harmlessly off the Shermans' armor. Their mortars began to drop shells, but the tanks were already too close, moving too fast. At 1:47, Reynolds's 12 tanks smashed through the German front line. They had crossed 3.1 miles of deep, soft sand in 23 minutes, an average speed of over 8 miles per hour, a speed that should have been impossible. Once they were behind the German lines, the Shermans pivoted and attacked the anti-tank positions from the rear. In 40 minutes of brutal, close-quarters combat, they destroyed 6 Pak-40 75mm cannons for heavy mortars and 11 supply vehicles. American losses: 1 Sherman damaged by artillery fire. 0 tanks bogged down. The German commanders were in a state of shock. They couldn't understand what had happened. Intelligence reports from the Afrika Korps dated October 25 made bewildered mention of new American tanks with improved sand-crossing capabilities. They had no idea that the improvement was 57 gallons of common ditch water per tank. Over the next 12 days of savage fighting, the modified Shermans conducted 43 deep penetration raids across terrain that had previously been considered impassable. The immobilization rate, due to bogging down, plummeted from a catastrophic 40% to a manageable 3%. The tactical impact was devastating for the Germans. Rommel had built his entire defensive strategy on the assumption that he could funnel Allied armor into predictable killing zones on firm ground. Caldwell's water-filled tires destroyed that assumption. The Shermans could now attack from any direction, across any terrain. On November 4th, the Afrika Korps began its general retreat. The Second Battle of El Alamein was over. Montgomery had secured the first major Allied land victory against Germany. Historians point to many factors: numerical superiority, air dominance, better logistics. But buried deep within the British tactical after-action reports is an interesting line. The Caldwell modification to Sherman suspension systems enabled armored operations in previously restrictive terrain, contributing significantly to breakthrough successes. The modification wasn't officially authorized by the U.S. Department of Ordnance until March of 1943, 5 months after Caldwell had first implemented it in the field. By then, 247 Shermans in North Africa had already received the unauthorized fix. The new directive, Technical Bulletin 449, formalized the procedure, giving it the bland, official name, Water-Ballasted Suspension Modification for Desert Operations. But the tank crews, the GIs who drove them and whose lives depended on them, had a much simpler name for it: Caldwell's Crazy Fix. James Caldwell was never brought up on charges for violating regulations. Instead, he was awarded the Silver Star. His citation reads, in part, for technical innovation under combat conditions which saved American lives and contributed significantly to the success of armored operations in North Africa. The official estimate concluded that his simple modification had prevented the loss of approximately 200 tanks and their crews from tactical immobilization. After the war, Caldwell returned to MIT, not as a student, but as a professor of mechanical engineering. In his lectures, he often told the story of the water-filled tires. His favorite lesson was a simple one. The best engineering solutions, he would tell his students, are not always the most complex. They are the ones that solve the real problem, not the problem you think you're supposed to be solving. The Caldwell modification was used by American and British forces across North Africa until May of 1943. Once the Desert Campaign was over, the tanks were returned to their standard configuration for the hardscrabble fighting in Sicily and Italy. But for those 7 critical months in the desert, 57 gallons of water per tank, an idea so simple it bordered on the ridiculous, had shifted the tactical balance of an entire campaign. It was a stark reminder that sometimes the difference between victory and defeat isn't found in the most advanced technology or the most sophisticated tactics. Sometimes, it's found in a 29-year-old engineer with a crazy idea, a man willing to break the rules because he understood that saving the lives of his fellow soldiers was more